is your video for 4-3, multiplying and dividing rational expressions. And one of the key things that we're going to be doing in this section is finding factors of fractional expressions and crossing out those common factors to reduce our fraction to lowest terms. One of the things that I want to point out with this section that's included with the notes is a factoring guide. This is just a review of some of the ways that we can possibly factor polynomials based on the number of terms. So we have 2, 3, and 4 terms, and it goes down through a list of things to check for. You should start checking at the top of each numbered column. So for example, if you have 2 terms, always check for a common monomial factor first, then check for difference of squares, then sum of cubes, then difference of cubes. 3 terms, check for common monomial factor, and then general trinomial. General trinomials, sometimes you'll have those where the highest term is a square. Sometimes you'll have them where the highest term is to the 4th power. 4th powers would factor the same way as squares, except for instead of factoring into an x and an x, it would factor into an x squared and an x squared. And then 4 terms, there's factoring by grouping. If you are not sure about factoring by grouping, because I don't think we've explicitly covered that in class, that is something that you can go on Khan Academy and check out so that you can complete those types of questions. So one of the key things that ties in here with these rational expressions is what we talked about in 4-2, and that's going to be where your denominator does not exist. So where we have not necessarily asymptotes, because if you have something that doesn't exist in a denominator, but we're able to reduce that term by factoring it out or crossing out those factors, we still have to express what the denominator cannot equal. So you can see here, we have the fraction x squared over x squared minus 9. That's an example of a rational expression. The denominator can't equal 0, so that means x squared minus 9 can't equal 0, which means 3 and negative 3 are the 2 values that x could not equal. The domain of this function then would be all real numbers except 3 and negative 3. So as we are moving through this section, if it asks you to state the values that the denominator cannot equal, you would have to consider where the original denominator is equal to 0. So here's our first example. First thing we always want to check for is a common monomial factor. Well, I see on top I can factor out an x, and I'd be left with x squared minus 5x minus 24. On the bottom, I can also take out an x, and I'm left with x squared plus x minus 72. So on top, I have a trinomial inside the parentheses. It's going to factor, I have an x and an x. Factors of negative 24 that add to make a negative 5. I'm going to have one positive, one negative factor, so I want negative 8 and positive 3. On the bottom, I want factors of negative 72 that add to make a positive 1. Again, I have my x and x, and then that'll be plus 9 and minus 8. Plus 9 minus 8. And then comes the fun part. That's where we go through and we actually cross out all the factors that are the same in the top and in the bottom. The only time you can cross out individual terms is if they are factors, like the x out in front. Since that x out in front is multiplied by the entire fraction, I am allowed to eliminate that. Otherwise, you cannot pull numbers away from the term that they are in parentheses with. Nor in the original problem could I have crossed out the x cubes, because x cubed is not a factor. X cubed is just a term. So we can't cross those out. However, x minus 8 is a common factor in the top and in the bottom, so we can eliminate that. We can cross that out. What I'm left with then is x plus 3 over x plus 9. Now, to go through and state all the values that x cannot equal, I want to go back to my denominator in this step before I cross things out. I want to set each of these factors equal to 0. So the x out in front gives me 0, the x plus 9 gives me a negative 9, and the x minus 8 gives me a positive 8. So those are the 3 values that x could not equal. Because if we plug them into the original question, I would get a 0 in the denominator. So your simplified form, which is what a lot of the questions are asking for, is going to have no common factors other than 1 in the numerator and the denominator. And we're going to be doing the same thing here in example 2. We are going to find the simplified form and then find the values where the domain value. So basically I want to state what's excluded. So my numerator has no common factors. 4 minus x squared, that is a difference of squares. So it's going to factor into 2 sets of parentheses, 1 plus, 1 minus. I take the square root of both terms and put them in parentheses. The bottom also has no common factors, but that's a trinomial. So that's going to factor, I'm going to have an x and an x. And then I want factors of negative 10 that add to make 3. That is going to be a minus 2 and a plus 5. Now, to cross out common factors that are the same in the top and in the bottom. Well, I don't actually have anything that's exactly the same. I have the 2 minus x in the top looks like it's similar to the x minus 2, but it's not quite what it needs to be. It's actually opposite. Because on the top, the 2 is positive and the x is negative. And on the bottom, the x is positive and the 2 is negative. So what we actually need to do for that is what my algebra teacher always used to call fudging when I was in school. And that means we need to factor out a negative. Because if we factor a negative out of this set of parentheses, so if I factor a negative out there, I'm going to get a negative 2 plus x, which is going to flip around to x minus 2. And then that negative can shift out into the front. Now we can go through and we have factors that we can cross out. So now we can cross out the x minus 2's, and we're left with negative 2 plus x all over x plus 5, or you can think of that as negative x minus 2 all over x plus 5. Now, as far as the exceptions for what x can't equal, x can't equal 2 because of the x minus 2 in the bottom, and negative 5 because of the x plus 5 in the bottom. And that would be your solution for that. Example 3 starts getting into some terms where we don't have anything being added or subtracted. Everything is being multiplied. The 2 and the x and the y are multiplied, the 4, the y, and the z are multiplied. It asks us about the product. Well, product means multiplication. So 2xyz times 3x squared over 4yz. When you multiply fractions, you multiply the tops and you multiply the bottoms, and we can reduce these top to bottom or diagonally. So before we even go through and combine, we can go through and cross out things that are the same. Well, I have a y in the top of the first fraction and a y in the bottom of the second fraction, so I can cross those out, and those are gone. My x's are both on the same level, so I can't reduce those. My z's are on the same level, can't reduce those. However, coefficients would reduce the same way that normal coefficients would reduce. So I have a 2 on the top and a 4 on the bottom. Well, 2 over 4 reduces to 1/2. So the 4 becomes a 2 and the 2 actually becomes a 1, which is really going to be inconsequential for our answer. Once you think you have everything reduced, you can multiply across. Well, 1 times 3 on the top is going to give me a 3. X times x squared gives me an x to the 3rd power. On the bottom, the only coefficient I have is a 2. And then I multiply the two z's together, and I get a z squared. Now, if it does ask you to state what the denominator can't equal, z could not equal 0, and y could not equal 0. Basically, if everything's being multiplied, whatever's in the bottom can't equal 0. Part B of the same question is doing the same thing we were just doing. It's just that now I have 3 different polynomials instead of 2. So I'm going to go ahead and recopy these. I'm actually going to factor as I go. The first one has no factoring to do. The top is a 5x, the bottom is x plus 3. I can't do anything with that. The middle fraction, though, the top can factor and the bottom can factor. So the bottom actually factors into x plus 1, x plus 1. That's actually a perfect square trinomial. So I could write that as x plus 1, the quantity squared. On the top, I have my x, and I'm looking for factors of -6 that add to make 1. So that's going to be plus 3 minus 2. And then the last fraction on top has a greatest common factor, that's an x. And on the bottom, I can take out a 5. And now I can go through and cross out things. Again, I can reduce top to bottom, and I can reduce diagonally. So one of the things that I see that's the same is the x plus 3. So that's gone. I also have an x minus 2 I can get rid of, and an x plus 1. Now I can't get rid of both of the x plus 1s in the bottom because I only have 1 in the top. There's one more thing we can get rid of, and that's the 5. The 5x is really a 5 times an x, so you can actually separate that 5 and reduce it with the 5 that's on the bottom. So now when I multiply across, I'm left with an x and an x, which is going to give me an x squared. On the bottom, I am left with x plus 1. And again, if it asked me what values x could not equal, well, because of the x plus 3, x could not equal -3. Because of the x plus 1, it could not equal -1, and the x minus 2 would make 2 not a possibility for our question. So example 4, this is another product. We do have a little bit of different factoring that we have to do here. We have a rational expression multiplied by a polynomial, but it's going to work out exactly the same way. So this is basically going to turn into a multiplication. This is going to have a 1 in the denominator. The top of the first fraction is going to stay x plus 2. The bottom, x squared minus 16, that is a difference of squares. That's going to factor into x squared plus 4 and x squared minus 4. Now here's something that doesn't happen very often. The x squared minus 4, that's actually another difference of squares. So this actually factors into x plus 2, x minus 2. So instead of carrying through the x squared minus 4, I'm going to use the x plus 2, x minus 2. The top of this fraction, I can actually take out, I'm going to jot this off to the side so I don't have to write a whole lot down to the bottom. I can take out an x, so I'm left with x times x squared plus 4x minus 12. And then that's going to factors of -12 that add to make 4 are going to be 6 and -2. So now we can go through and cross out factors that are the same in the top and bottom. Well, I have this x plus 2 and that x plus 2 are gone. This x minus 2, that x minus 2 are gone. So I'm left with, because there's nothing else I can reduce here, x times x plus 6 in the top and x squared plus 4 in the bottom. The exceptions for x could not equal -2 because of the x plus 2, +2 because of the x minus 2. The x squared plus 4, that would actually give you plus and minus 2i. but I'm only considering the real numbers here because this is a rational expression, so I do not have to account for that whenever I state what x can't equal. The last question we're going to look at today is finding the quotient. Quotient is the result whenever you divide. So this is a division question. When you divide fractions, you change the sign to multiplication and then you flip the second fraction. So the x squared plus 3x minus 4 goes on top, and the x squared plus 5x plus 4 goes on the bottom. Now we have to go through and do our factoring and figure out what crosses out and what we're left with. So the top of this first fraction, the x cubed, this might look like something you're like, I don't know what to do with this, but the 1331 should send off a bell, like an alarm bell, like, oh, I've seen that before, 1331. That is from Pascal's triangle. That is actually x plus 1 to the third power. On the bottom here, this is a DOS that's going to factor into x plus, or 1 plus x and 1 minus x. Now in the top, factors of -4 that add to make 3 are going to be plus 4 and minus 1. In the bottom, factors of 4 that add to make 5 are 4 and 1. And now we can go through and cross some things out. We can cross out x plus 4s. I can get rid of this x plus 1 with one of the ones that are up on top. We do have a slight issue here, because I have an x minus 1 and a 1 minus x. Well, remember, those aren't exactly the same, so I need to take a negative out front to turn that into an x minus 1. And then I can get rid of the x minus 1s. So now I'm left with x plus 1 squared over a negative and then parenthesis 1 plus x. Well, 1 plus x is the same thing as x plus 1. You don't even need to factor a negative out because the 1 and x are still both positive. So I can actually reduce that with one more of the x plus 1s in the top. So when all is said and done, I'm left with x plus 1 divided by -1, so negative x minus 1. And then my exceptions for what x can't equal are going to be 1, -1, and -4 for all the values that were in the original denominator. All the values that are in the denominator there. Notice I'm considering new denominator and old denominator because they both count. So there is another example that you'll see in the PDF, for example 6. It deals with ratios of some different volume formulas. I'm not going to go over that. That is in your textbook if you want to read over that. So go back through, watch this video. There are lots of resources out there online for simplifying these rational functions whenever you're doing multiplication and division. So make sure you seek those out if you need any assistance. And feel free to contact me if you have any questions.